Let's continue applying the log rules for integration with some slightly more complicated examples. The first one is the natural log of x squared divided by x dx. So typically we've been dealing with cases where the substitution expression is in the denominator. However, in this particular one, we're going to be a little more clever and say, okay, well, I've got a natural log of x on top and x on the bottom. So how do I do this? Well, what I would do is I would say, this is the natural log of x squared times 1 over x dx. So part of what you do when you're dealing with any kind of u substitution is you're trying to figure out if you can find both an expression and its derivative inside of the integrand. And in this case, it looks like we can if we choose u to be the natural log itself. So if I say u is natural log of x, then du is 1 over x dx. So by doing that, what I see is I have the derivative here and I have the original expression. So then I can replace this with u squared du, which of course is just 1/3 u cubed plus an arbitrary constant, which we then can replace with 1/3 natural log of x cubed plus the arbitrary constant. So that one was a little trickier with our substitution. The next one is going to follow a very similar vein. What we're going to do is we're going to say, okay, I've got this natural log of x, but that natural log of x is cubed. All right, how do I deal with this? Well, we can do this a number of ways, and I'm going to show you one way, but there are other ways to do this. The first one is to say, all right, the natural log of x cubed, now what's its derivative? Well, what you find for the natural log of x cubed's derivative is that it's 3 over x. So if I say that u is the natural log of x cubed, then du is 1 over x cubed times the derivative of x cubed dx. Well, in that particular case, that's 3 over x dx. But I don't have a 3 over x here. What I do have is dx over x. So I can say 1/3 du is 1 over x dx. Now rewriting this, what we can say is this term is 1 over natural log of x cubed to the 5th times 1 over x dx. So then this becomes 1 over u to the 5th times 1/3 du. But then we can rewrite that as 1/3 u to the negative 5th du, which is you add 1 to the power and then divide by the new power, so you end up with negative 1/12 u to the negative 4th du plus an arbitrary constant, not a du, sorry, plus the arbitrary constant. Then that's like negative 1 over 12 u to the 4th plus the constant, which is negative 1 over 12 natural log of x cubed to the 4th plus the arbitrary constant. So I mean, that's pretty ugly, I'm not going to lie, but that's how you do that sort of problem, just one step at a time. That's the big thing here, just one step at a time. And finally, we have something with trig, and this one's a little simpler, but trigonometric substitution is always a little bit dicey for people when they get used to it. Or rather, substitution using trigonometric functions. Trigonometric substitution is actually a separate concept. So in this particular case, if I look at this, I go, okay, well, the derivative of sine function is cosine. So if I say that this is 1 over 2 minus sine of t times cosine t dt, all right, well then, if I let u equal 2 minus sine of t. The du is negative cosine t dt. So then negative du is cosine t dt. All right, that'll absorb that. So now I have 1 over u times negative du, at which point I can pull out the negative. 1 over u du, which we know is negative natural log of u plus c. Again, remembering that we do always get that absolute value here. Never forget that. Which is negative natural log, absolute value 2 minus sine of t plus c. You could also remember that 2 minus sine of t is always going to be positive, so you don't really need the absolute value here, but whatever. And that's the next set.